Okay, so we're going to tie our division of polynomials and this remainder theorem into factorising polynomials. So at the moment, to find our remainder, we do the division and whatever's left over is left over. Well, there's a much quicker way. So if we're dividing a polynomial by some ax plus b, well, the remainder we can get by substituting in minus b on a. So in other words, if I'm dividing by 2x plus 1, well, there's the b term, there's the a term, I work out p of negative 1 on 2. If I divide by x plus 1, I work out p of minus 1. Divide by x minus 6, I work out p of 6. And that will give me my remainders, okay? So for practice as much as anything, we'll do both methods here. So if I decide to do a division, and I'm going to do it sort of the longhand way, remember we put a 1 out the front because it's a negative 1 there. I go 1, negative 1, negative 3, positive 1. And we did this problem a little bit earlier. So bring the 1 down. 1 times 1 says no, the coefficient of x is 1 in here, so I don't have to divide by anything. 1 times 1 is 1. Add them together, I get 0. 1 times 0 is 0. Add them together, I get negative 3. 1 times negative 3 is negative 3. Add them together, I get negative 2. There's my remainder. All right. Now, I should get the same answer by working out p of, it's a negative 1 there, I put positive 1 in. So I get 1 cubed minus 1 squared minus 3 times 1 plus 1, which is 2 minus 4, which equals negative 2, which is the same answer, okay? So that's the quickest and best way to work out our remainder, all right? I've done this division in our previous examples. So if I just want to go straight to working out the remainder, well, that's b on a, so it's 1 on 2, but negative. And we'll go for negative a half cubed plus 3 times negative a half squared minus 5 times negative a half plus 7. So what's that equal to? That's equal to minus 1/8 plus negative a half squared is positive a quarter, so it's plus 3/4. Negative 5 times negative a half is plus 5 on 2 plus 7. So to add them together, I've got to make them all the same denominator. So let's make them all over 8. So I get negative 1/8. 3/4 is the same as 6 on 8. 5 on 2, multiply both by 4, is the same as 20 on 8. And 7 is the same as 56 on 8. So that gives me, 76, 82 minus 1, 81 on 8 is my remainder, okay? So it's the simplest and most efficient way of working out the remainders is just by substituting in the negative b on a form of the whatever we're dividing by. There are sometimes some practical applications. When p of x is divided by x minus 2, we get a remainder of 4. So first things first, I've got to find the value of a. So how do I work out the remainder? Well, I substitute in p of 2. And this question tells me I should get 4. So what is p of 2? Well, p of 2 is equal to 2 cubed plus 2 times 2 plus a, which is 8 plus 4 plus a. So I get 12 plus a, and that has to equal 4. Therefore, a equals minus 8. All right. So there's just some routine applications where we're just trying to find a remainder. Don't do the division, okay? We just substitute in that key value. And then sometimes we might need to use that information to find some unknown values. All right, off you go.